Welcome to my physics classes, philosophy of physics. Students, today we'll do a vector part and the vector product from the vector analysis part. But first and foremost, I want to tell you, please do like, share and subscribe my channel to get more endeavor to give much more performance in front of you in day-to-day basis. Thank you. Now, today we'll learn vector product. Vector product. Previously, what we have learned, like vector A, this is an analytical part I'm telling you, vector B. If vector A and vector B in the same plane, this is vector A, this is vector B. So if we multiply, so the vector product will be what? Obviously A cross B. This will be. So this whatever this A cross B produces, this A cross B produces a third vector. Let this vector be C vector. So what we can write, the C vector will be A into B. So whatever, this is automatically like this. If this is A, this is B, this is C. So this will be three vectors. So we'll get like this. From this, we'll get the right hand rule. From this, keep it in mind, from this vector product, we will get right hand rule of vector, right hand rule of vector. So if A vector and B vector are parallel, if A vector, this is A vector, this is B vector, are parallel. If A vector and B vectors are parallel, so this A into B will be 0. Keep it in mind. If it's parallel or anti-parallel or anti-parallel or anti-parallel, like this is A vector, this is B vector, the cross product will be 0. Again, if we get like this way, vector multiplication is obviously important. So vector C will be finishing like same, like this vector will be sorry, it will showcasing like this way. If the showcase like this way, this will showcase. So what we'll get from here, this as well as this. In this case, if it is in the opposite direction, if in this case, if it's in the opposite direction, it will be like this, obviously. As we know in the previous addition cases also, if you change, we just change the sign before the addition. In unit vector notation, what also we can write, vector A cross vector B is equal to, we can, what we have learned previously, the component of x, so it is I, component of y, ay, it is j, plus component of z. As because of A, B, C, 3 are there, so we'll get az. So az will key cap. So this will into this, B will come. So what will be bxi plus byz cap plus bz j k cap. So this is the scenario in the unit vector notation. So what we have learned the unit vector notation, this is the scenario. In the distributive law also, which can be expanded according to the distributive law. It can be expanded, it can be expanded according to the distributive law. So it can be a distributive law that each of the component of the first vector is to be crossed with each component of the second vector. So what we can write this, the cross product of the unit vectors. So the cross product of the unit vector, cross product of the unit vector cross products of the unit vector are given, can be written as follows. What? Ax I into bx I is equal to ax bx I into I is equal to 0, because two unit vectors I and I are parallel. This is the two unit vectors are parallel. Unit vectors are parallel, thus have a 0 cross product. Similarly, as because of two unit vectors are multiplied in the parallel form, we got 0. Similarly, if we multiply like this way with the component axi into bx, we are changing this format, bxj. So what will be by ax by will be I cap into j. So I cap into j cap, so it will be what? Ax by I into j, it will be give you k cap. Okay, so these are the situation we have so far discussed. Equation what we got, let it be equation number 1, equation number 2, equation number 3. So from 1 we can say expanding, we will get what we'll get, a to b, what we'll get a to b will be ay bz minus by az into I, by az into I plus azbx minus bzax minus bzax ij plus abc ax by minus bx ay ij k cap I cap. These are the situation. So we'll get this equation a cross b, keep it in mind. So for the using of unit vector notations, what we have got here as a notation, if we multiply a cross b vector, we got like this. This is geometrically presentation. A B, C geometrically. So when we cross multiply to the A vector into B vector, we got a third vector into the C vector. So along with this, what we are the other thoughts and theories like this: if this A vector and B vectors are parallel, so it will be 0. If opposite, anti-parallel, it will be also be 0. So from this anti-theory B into A we got. So again A into B minus for the negative approaches, left side approaches of the vector B. If we got this and if we got this along with this, so if we got this x, y, if it's 0, so for this we got minus A into B. I think you got it. Similarly, in unit vector notation, as we have earlier, what we know, we knew that all the components of the vectors are ax, we did ax, by, and cz, ax, by, right? Like this: ax, ay, az, bx, by, bz, like this: cx, cy, cz. All of the components later on we added with the unit vectors. For the unit vector notation, what we have learned, a cap in the I. So this ijk signifies A vector, B vector, C vector accordingly. So here A into B, A vector into B vector, what this component vector using component also, ax, I, ay, z according to y, z. For the z it is k. So using this unit vector notation, just similar, but we did a little bit change. We changed into unit vector. This simple A vector we have changed into this unitary theory, unit vector theory. Bx I plus by z. So similarly we got this. So vector A cross vector B, from here we got this. So according to this, the product, one after one will get component of this axi, bxi will get what? Similarly, this will be 0. What? We got 0. We applied this also here. We got second part. I into I, this unit vector. These are vector parallel to the line 0 cross product. So for the using unit vector, general applications of vector and the unit applications of vector, it crosses, gives you 0. Similarly, we will get x I cap into by j cap is equal to ax by. This is what? This is cross product and this is not the parallel. This is perpendicular, I and j. So you have to learn this I and this is j. This is perpendicular to each other. Here the parallel to each other is the perpendicular to each. The perpendicular gives you the k vector. So unit vector k cap. So ax by, it gives you the ax by k. So from this, as I told you previously also, from 1 we can say, or expanding this a cross b. We have done this, we have done this a cross b. Now we did this a cross b, expanding, because of we are expanding one step ahead. So I j k. So for the I, y, z, yz, we have learned I for x. So keep it in mind always, here no x notations are there for the cases of I. Cases of j, no y notations are there, because we know like this is x, this is y, this is. So just this is a thumb rule. If ay bz minus by az for the a cross b vector, so you will not find x related any terms here. I is there because I denotes for the x vector. Similarly, z denotes for the y vector and k denotes for the z vector. So when xy is there, so z is outside, means k is outside. When zx is inside, j is outside, means y, and yz is I, means x. So always keep it. These are the thumb rules. When you go for the doing some numericals, it will keep you help. That's all.